Now let us try to understand about output delay, which is max. We already know like max output delay is used for setup analysis, and for setup this condition should get satisfied so that there won't be any violation. So see this particular figure. So after reaching O1, how much time it is taking to reach to the data pin of flop F3 is something which is called as set output delay. And here if you are taking max value, it should be indicated with set output delay hyphen max. If it is min, use the switch called as hyphen min. And one more thing, for max analysis, C1 will have more amount of delay. Now let us try to understand about data arrival time. So these are the same values which we are continuing as of now. Time period is 10 nanosecond, source latency is 0.5 and network latency is 0.7 nanosecond. So this is the figure which we are considering. So first one, clock rising edge. So we are considering the first trigger. So active edge of clock triggering the flop assumed at 0. So rising edge is at 0. Next, clock latency is 0.5, network latency is 0.7. So this total delay will get added up with 0.5 and I'm getting output as 0.5. Now this 0.5 will get added up with 0.7 and I'm getting here as 1.2. Here one important point that you need to remember. Read this blue colored line. So C2 and C3 is something which is present outside block B1. So it is not included in the arrival time calculation. So for arrival time, we are considering only block B1. We are not considering this C2 and C3. And here this red color line, I mean this circled one indicates clock to Q delay followed by C1 which is maximum. So this clock to Q delay followed by C1 max, the value which we are taking is 1.5 nanosecond. See this point, here this max delay we have to consider. So delay through C1, here we are taking the max value which is something which we are assuming it as 1.5. So this 1.2 will get added up with this 1.5 and I'm getting output total delay as 2.7 nanosecond. So data available at O1 is 2.7 nanosecond. So at this point, data will be available by 2.7 nanosecond. So simply, initially when clock is getting triggered, the delay is 0 followed by clock latency, I mean source latency, network latency will get added up, followed by this clock to Q delay followed by combo delay. So total delay is 2.7 nanosecond. And if you want to calculate it by means of formula, use this one. Arrival time is source latency, network latency, clock to Q delay followed by C1 plus C2 plus C3. But here you should not use C2 and C3. So here the formula will be only arrival time, clock source latency, network latency, clock to Q delay followed by C1. Only we have to take it till C1. C2 and C3 are not considered. Why? Because C2 and C3 is something which is present outside block B1. So it is not included in arrival time calculation. So that's why source latency is 0.5, network latency is 0.7 and total clock to Q delay followed by C1 max value is 1.5 nanosecond. If you add all this, you will get time as 2.7 nanosecond, which is called as arrival time. So the same thing I'm showing it here, but here I've removed C2 and C3. So at port O1 of block B1, so here clock to Q delay followed by C1 max is nothing but delay through C1. So for this particular one delay and everything is same. So clock to Q delay followed by C1 max I'm taking as 1.5 nanosecond and arrival time that I'm getting is 2.7 nanosecond. And this is the formula where we are taking only source latency, network latency, clock to Q delay followed by C1. We are not taking C2 and C3. I hope you understand this. Why? Because C2 and C3 is something which is present outside block B1. So that's why we are not considering it here. So total arrival time is 2.7 nanosecond. Now let us see about the required time. So for required time, we already know. For setup calculation, we are considering the next positive edge of the reference clock. So here next triggering is happening at 10 nanoseconds. So delay is 10 nanoseconds followed by source latency 0.5, network latency 0.7. So this value will get added up. 10 plus 0.5 will give 10.5. 10.5 plus 0.7 is 11.2. Now, as we are going for setup analysis and we are calculating the required time. So required time is something which will be calculated at flip-flop F3. So for this particular flip-flop F3, we need to know about the setup time. So setup time is something which will be present between clock pin and data pin, and this value we get from the dot lib. Okay. So what I'm doing here is max output delay specified as 6. So that setup requirement which we are considering is 6 nanosecond. So here the set output delay plus setup time of flip-flop F3 put together is 6 nanosecond, which is nothing but C2 plus C3 plus setup time of flip-flop F3 is 6. So put together C2 plus C3 followed by the setup time, the value that I am getting is 6 nanosecond. Don't get confused with this point. So the C2 and C3 delay is something which is indicated with set output delay hyphen max, and I'm taking that particular value. So this 11.2 minus 6 will give 5.2. Why we are subtracting? Why? Because for setup calculation, the thing which we need to follow is total time period minus setup. So till now we got the delay as 11.2 and 6 should be subtracted from this. So 11.2 minus 6 will give 5.2, followed by uncertainty should also be subtracted. So that's why 5.2 minus 0.2 is giving 5. So data required time is 5. If you want to calculate it in terms of formula, it is time period minus setup minus clock uncertainty plus source latency plus network latency. So we know that time period is 10 nanosecond. Setup time put together including both C2 and C3 delay is 6. Uncertainty is 0.2. Source latency is 0.5. Network latency is 0.7. So if you substitute this, you will get the time as 5 nanosecond. So totally we got required time as 5 nanosecond and arrival time as 2.7 nanosecond. So for setup time, required time should be greater than the arrival time. So required time is 5, which is greater than 2.7. So it is satisfying the condition. So slack is something which will be positive. So that is slack is equal to data required time minus arrival time, which is 5 minus 2.7 is 2.3. So slack is positive. So setup timing path is met. If this is getting satisfied, you will see here as met. If it is not satisfying, then you will see here as violated. Remember this point. So first of all, be cleared with this circled path. Here I am taking it as setup requirement, but it is something which is C2 plus C3 plus setup time. Whereas the C2 and C3 is something which is indicated with set output delay hyphen max.